Hi there, and thanks for watching. This is Lab 1, Charged Tapes. Introduction. The purpose of this lab is to prepare charged pieces of tape, observe the interactions between those pieces of tape, determine whether there is a positive or negative charge on the tape, determine the approximate amount of excess charge on the tape, and to simulate the experiment in Python. So, to summarize the findings, the excess charge on the tape according to the point charge model was found to be 1.2 e negative 8 coulombs. The excess charge on the tape according to the line charge model was found to be 1.7 e negative 8 coulombs, and the excess charge on the tape according to the computational line charge model was also found to be 1.7 e negative 8 coulombs. The most important concept in this lab is electrical force. We're also going to be using the superposition principle and the equation for an electric field due to a rod. Gravitational force is also an important concept. And finally, we're going to be using Newton's third law, which states that for every action there is an equal and opposite reaction. Next, we'll go over the model. First, some key assumptions. For both models, we're assuming that both tapes have the same amount of charge, and that the force holding down the upper tape while it's suspended is negligible, and we're assuming that the mass of the tape is 0.1 grams per meter. For the point charge model, we're approximating both charges to be a point charge. For the line charge model, we're approximating the upper tape to be a point charge and the lower tape to be a line charge. And for the line charge computational model, we're approximating both tapes to be a line charge. This is the simplest version of the model. Essentially, the gravitational forces balance out the electrical forces. In this version of the model, as you can see in the upper right-hand corner, the upper tape and the lower tape are approximated to be point charges. This is a similar model. The only difference is that we're approximating the lower tape to be a line charge. Finally, this is the computational model, which approximates both pieces of tape to be a line charge. Experiment and result. These next few slides will be an overview of the experimental procedures. To start with, the tapes were charged. Then the interactions of the tapes were tested. And finally, an upper tape was suspended above a lower tape in order to test what the displacement would be. So here are the observations. First of all, two tapes repelled one another. A tape and a hand attracted one another. Tape and a pen attracted one another. And the separation distance between the upper tape and the lower tape was 0.035 meters. The result that we got for the point charge model was 1.2 e negative 8 coulombs. And the result that we got for the line charge model was 1.7 e negative 8 coulombs. We'll look at the code for both the point charge and line charge models. This is the first half of the computational model where we initialize our constants and our variables. Note that the upper tape is located at the distance along the y-axis, where the lower tape is located at the origin. In the point charge computational model, we calculate the gravitational and electrical force on the upper tape, and we draw an arrow for each. Here's the output of the point charge computational model. The gravitational force on the upper tape is represented as a red arrow. The electrical force on the upper tape is represented as a blue arrow, and the upper and lower tape are represented as white spheres. Here we're looking at the setup for the line charge computational model, where we initialize our constants. There's also a function to model a line charge, which is used to model the top and bottom tape. Finally, the electric force is calculated by iterating over the charges along the bottom tape and the charges along the top tape, and summing up the electric force between each of those two charges. This is the output of the line charge computational model. The blue spheres represent the bottom tape, the red spheres represent the upper tape, the yellow arrow represents the gravitational force on the upper tape, the white arrow represents the net electric force on the upper tape, and the green arrows represent the electric force at different points along the upper tape. Note that the magnitude of the electric force is roughly equal to the magnitude of the gravitational force. The reason for this is that the charge was modified by trial and error in order to get these two values to be roughly equal. In summary, the model predicted that the electric force would balance out the gravitational force, which is what we saw. Some possible sources of error. First, the charges of the tape may have been different due to handling. Second, the shape of the tape was different than the model predicted. And third, the upper tape may have gone higher if it wasn't. But what if electrons had a positive charge and protons had a negative charge? In this case, the charge of the tape would be the opposite, but all other results would remain the same. So why is the estimate for the line charge higher than the estimate for the point charge? On the line charge, the charges are distributed farther apart, which means that a higher charge is required in order to counter the gravitational force. Again, this was Lab 1 Charged Tapes. Thanks for watching and have a great day.